So lesson 7.3 is where a lot of things come together. Wow, that is a very interesting looking horse. You see that? It's very strange. It's cool. It's good. Anyway. A lot of things start coming together in lesson 7.3. And we start to see why we've done a lot of things. It's called applying the zero product property to solve equations. Now, the zero product property might seem like it's something new, but you've actually been doing it for a long time. But if we want to begin, we have to understand what the zero product property is. Okay, so it says, for all real numbers, a and b, the following is true. Words. If the product of two quantities equals 0, at least one of the quantities equals 0. Well, what does that mean? 9 times something equals 0. What goes in that box? 0. It's got to be, right? It's got to be 0. 9 times 0 equals 0. If a times b equals okay. What about this here? 0 times 4. What goes there, class? 0, right? Okay. If ab equals 0, so look, 9 times 0 equals 0. 0 times 4 equals 0. If a times b equals 0, then either a is equal to 0 or b is equal to 0. That's what the zero product property tells us. One of them's got to be 0. If this product is 0, then either a has to be 0 or b has to be 0. It's the only way that's possible. They could quite obviously both be 0, but that's less of the situation we're talking about today. What we're talking about today is the fact that if one of them is 0, then the product is 0. So let's go ahead and consider this equation. X minus 3 times x plus 8 equals 0. Well, let's let a equals x minus 3 and b will equal the other one, x plus 8. Since a times b is equal to 0, you know that a is equal to 0 or b is equal to 0. Therefore, either x minus 3 is equal to 0 or x plus 8 is equal to 0. Well, that's great. But if we know that either this is equal to 0 or that is equal to 0, we can go ahead and solve for x in both of those situations. So in order to do that, we add 3 to both sides, we get x equals 3. We subtract 8 from both sides, we get x equals negative 8. And we find that the solutions of this equation, x minus 3 times x plus 8 equals 0, are positive 3, x equals positive 3, and x equals negative 8. So what did we do here? Well, what we did is we used the zero product property, which says that if a times b is equal to 0, then a is equal to 0 or b is equal to 0. Right? So either x minus 3 is equal to 0 or x plus 8 is equal to 0. And then we solve for x in either one of those. Oh, sorry. I was trying to be slick about it. Okay. Not quite sure that was actually a sign. It was more just like a gesture. All right. So what did we do? We know that this product AB is equal to 0. Therefore, either A is equal to 0 or B is equal to 0 by the zero product property. Well, if this is equal to 0 or that's equal to 0, the only way for that to be possible is if x equals 3 or x equals negative 8. So the solutions of this equation are x equals 3 and x equals negative 8. Why? Because if I plug in 3 here, 3 minus 3 is 0. It doesn't matter what this is. It's 11, but 0 times 11 is still 0. If I plug in negative 8 here, negative 8 plus 8 is 0. It doesn't matter what this is. It's negative 11, but negative 11 times 0 is still 0. Does that make sense to you guys? Is that clear? Okay. So, you guys have done that before. Most of the time, you guys would just see this and be like, oh, okay, I know what to do. I just set this one equal to 0, and I set this one equal to 0, and I solve. So you've done this many times before. Now we're just giving it a name. It's called the zero product property. The reason why you can do that is because the zero product property exists. And the zero product property says, if this times this is equal to 0, then either this is equal to 0 or that is equal to 0. Okay. So recall that the solutions of an equation are the zeros of the related function. So the solutions of this equation here are the zeros of the related function x minus 3 times x plus 8. What's another name for the zeros of a function? Something intercepts? X. X intercepts. The x-intercepts, the zeros of the function, are the solutions of this equation. Remember, the zeros of the function are where the function is equal to 0. Okay, so the solutions, or the zeros, this should say zeros, of the related function f of x equals x minus 3 times x plus 8 are 3 and negative 8. Okay, so let's move forward. Oh, I should take roll. Okay. Who's absent? Chris, Isaac. Sally here? No. And Matthew, Olivia, okay, good. All right. So, applying the zero product property to functions. Guys, this is pretty straightforward, okay? When given a function of the form f of x equals x plus a times x plus b, you can use the zero product property to find the zeros of the function. Okay? Hold on one second. Sorry, guys. Okay. So you can use the zero product property to find the zeros of the function. Guys, this is pretty straightforward. Look, you have x minus 15 times x plus 7. We set the function equal to 0, which means x minus 15 is equal to 0, x plus 7 is equal to 0. So you set them both separately equal to 0. You solve for x. You get the zeros. Okay, go ahead and do that for step B. Just go ahead. It's like a mirror image, basically. It's the same thing, so. Those boxes. Bless you. All right. So first thing, set the equation equal to 0. Set it equal to 0. Set them both separately equal to 0. Solve for x. Here we subtract 1, we get negative 1. Here we subtract 23, we get negative 23. So the zeros are negative 1 and negative 23. Simple as that. Okay. And just so we can confirm this visually, remember the zeros of the function are where the function is equal to 0. So if I were to plug in x plus 1 times x plus 23, well, we see one here is at negative 1. I got to zoom out to see the other one here at negative 23. So there you go. So there's the zeros of the function. All right. This is a good one. Reflect. Discussion. Jordy was asked to identify the zeros of the function f of x equals x minus 5 times x plus 3. Her answers were x equals negative 5 and x equals positive 3. Do you agree or disagree? Explain. Raise your hand if you agree with her that she got the right answer. Raise your hand if you disagree. Okay, good. So you disagree. Gabriella, why did you disagree?
Because when you do x minus 5 equals 0, you have to add 5 next.
Very good. When you set this equal to 0, you'll end up with x equals positive 5 because you'll add 5 to both sides. So this should be positive 5, and this you would subtract, right? So you get negative 3. Another way you could check is just by plugging it in, right? Negative 5 minus 5 is not 0, it's negative 10. And 3 plus 3 is 6. So you can tell that those are not zeros. Number 3, how would you find the zeros of the function f of x equals negative 4 times x minus 8? This is a really good one. You might be inclined to set them both equal to 0 and say, well, okay, negative 4 equals 0 and x minus 8 is equal to 0, because there's these two different terms here. But what's wrong with this first one?
Doesn't have an x.
There's no x, yeah. And if you just look at that, I just wrote down negative 4 equals 0, right? That's just wrong, right? Negative 4 does not equal 0, right? So you can always check that way if you're confused, but the point is you don't have an x there, so there's nothing to solve for, right? It's just a constant, all right? But this one is a little bit different. This might confuse you as well. What are the zeros of the function f of x equals x times x minus 2? X minus 12, rather. Well, again, just set them both equal to 0. Okay, x equals 0 and x minus 12 equals 0. This might confuse you because you say, oh, don't I have to add something or solve? Well, no. It's already solved. Your 0 is right there at x equals 0. And then solve for that one by adding 12 to both sides. And what would this look like visually? X times x minus 12. There are my zeros at 0 and at 12. Does that make sense? Okay. Go ahead and do numbers 5 and 6 on your own, please. Find the zeros of each function. But it's okay for now. If you can see that and feel confident in it, that's okay. All right. Homecoming. Oh, I missed it. Dismiss. Okay. Set them both equal to 0. X minus 10 equals 0, and x minus 6 equals 0. Add 10 to both sides. X equals 10. Add 6 to both sides. X equals 6. Here, obviously, I'm not concerned about that 7. X minus 13 equals 0. X plus 12 equals 0. Add 13 to both sides. X equals 13. And subtract 12 from both sides. X equals negative 12. Now, you can see when it's simple like that, well, if it's x minus 10, it's just 10. It's just the opposite. If it's x minus 6, it's just 6. If it's x minus 13, it's 13. If it's x plus 12, it's just negative 12. Right? But as it gets a little bit more challenging, that becomes a little bit less obvious. The solutions become a little bit less obvious. So, next. So this is our next point here. You guys feel good about that? You feel pretty solid on that? Good? On good, strong ground. now we're going to learn a skill that, does anyone remember factoring by grouping? Anybody? Factoring by grouping? Well, factoring by grouping is a skill, and this, what we're doing here, is actually kind of a precursor to that skill. It's like a little tool that we'll add to our toolbox. Let's take a look at this. We have 3x times x minus 4 plus 5 times x minus 4 equals 0, and it asks us to find the solutions. So that looks a lot different, so obviously we're going to have a different approach here. Let's take a look. Okay, before I do that, if I had 2x plus 4 equals 0, could I pull something out of these terms, both these terms? They have a shared term. 2, yes, so I can pull that out. I can distribute that out, use the distributive property to pull that out, and this becomes 2 times x plus 2 equals 0. Because if I went and distributed in, I would get 2x plus 4. So it's like, it's the distributed property, but it's the kind of backwards, it's pulling it out than what we're used to doing most of the time. So that's using the distributive property right there. But let's now take a look here. 3x times x minus 4 plus 5 times x minus 4. Do those share a common factor, both of those things? What's the common thing? X minus 4, right there, okay? So instead of just like pulling out a 2, I'll pull out this x minus 4. And so I get x minus 4, that term there. And that's times 3x, that's the first one, just like here was my first one, plus 5, that's my second one, just like this is my second one. So I got 3x plus 5 equals 0. You see? Does that make sense? Do you guys see what I just did? I just pulled this x minus 4 out, and then these two terms that were in the front here, I brought them together. Put them in the same parentheses. What was that? No, because you basically just did the opposite. If you were going to FOIL right now, you might as well have just distributed those terms in and combined like terms and stuff. We're not looking to FOIL right now. We're looking to find the zeros. So why did we do this? Well, we did this to get it into that form like x plus minus a and x minus b. Remember? Because now we can find the zeros directly. Because look, we have a times b equals 0. So what's the next step to find the zeros? We set them both equal to 0. You see? So we had to get it into this form, and we did that by pulling out that like term, x minus 4. Good question. Okay, so now we set them both equal to 0. We get x minus 4 equals 0, and 3x plus 5 equals 0. Now we solve for both. Here we add 4 to both sides, and we get x equals 4. This one is a two-step equation. So we subtract 5 from both sides, we get 3x equals negative 5, and then divide by 3. And we get x equals negative 5/3. And those are our two solutions. X equals 4 and x equals negative 5/3. Does that make sense? Yeah? Okay, so let's go ahead and, that's already there in your book, so there's no need to like really copy that down. It's just right here. Let's go ahead and do that next one, part B. Use the distributive property, rewrite negative 9 times x plus 2 plus 3x times x plus 2. Well, it's what plus 3x? It's this negative 9 term out front here times x plus 2. Then I set them both equal to 0, negative 9 plus 3x times x plus 2. And then individually set them equal to 0. Right, so what did I do here? I distributed out the x plus 2, and then this term negative 9, and this term 3x. How far to get it? Then I set them both equal to 0, and then I solve. Here I have to add 9 to both sides. That's my first step. I'll end up with 3x equals 9. Here I subtract 2 from both sides. I end up with x equals 2. This one's done. But then here I have to divide by 3, and I get x equals 3. So the solutions of my equation are x equals 2 and x equals 3. And it's definitely not a hard and fast rule, but generally when you're listing zeros, you should list them. What was that? Yeah, sorry. When you're listing zeros, you should list the smallest one first. So this should be negative 2. Sorry about that, guys.
So it has to be worded like that, negative 2, 3?
Nope, sure doesn't have to. That's why I said it's definitely not a hard and fast rule. It's not like I would take off points if you said x equals 3 and x equals negative 2, because that's technically correct. But generally speaking, it's good to organize it that way. Okay, and there are reasons, but that's kind of the rule of thumb, if you will. Okay, any questions on this? Okay, that was a little bit more complex of an idea than what we started with. Okay, now we're going to do something a little bit more. So how can you solve the equation 5x times x minus 3 plus 4x minus 12 equals 0 using the distributive property? Well, let's take a look at this. We don't have like something times x minus 3 plus another thing times x minus 3. So it's not the same form, but that's the form we want to get it in. So is there any way we could get this thing here, 4x minus 12, to be something times x minus 3? Yeah?
12 to both sides.
Well, we don't want to add 12 to both sides because then we'll end up with something over there. We want a 0 over there. Any ideas? How can I change this? What can I do with this? Yes? Pull out a 4. Very good. If I pull out a 4, look, I end up with 5x times x minus 3 plus 4 times x minus 3 equals 0. Very good. Okay. And now that I have this similar term, x minus 3, now I can group them. 5x plus 4 times x minus 3 equals 0. My first term and my second term, 5x plus 4 times x minus 3 equals 0. And now what do I do, class? I set them both equal to 0. So I do 5x plus 4 equals 0, and then x minus 3 equals 0. Here I subtract 4 from both sides. I get 5x equals negative 4, then divide by 5. X equals negative 4/5. And then here, I simply add 3 to both sides. I get x equals 3. So those are my solutions. Does that make sense? Okay, everyone do numbers 8 and 9 on your own, please. Go ahead and do numbers 8 and 9 on your own. seconds.
Shoot. Sorry. Oh, sorry about that. You can follow along on your computer if you want to.
That's rough. Sorry about that.
All right, let's take a look. All right, number 8 is already kind of set up for us. So all we have to do is group the terms 7x and negative 2. So we have 7x minus 2 times x minus 11 equals 0. Set them both individually equal to 0. 7x minus 2 equals 0 and x minus 11 equals 0. Here we then add 2 to both sides and we get 7x equals 2 and then divide both sides by 7. We get x equals 2 over 7. This one is it's more simple, just a one-step equation. We get x equals 11. So those are solutions for our first one, number 8. And our next one here, what do I pull out of these two terms here? 3, good. So I pull out a 3. And class, I want you to notice something, okay? If this was 19, would that have worked? No. So these problems are very specific. They have to be set up in very specific ways in order for them to work in this way. Does that make sense? So you can trust on this test that I'm not going to give you some crazy thing that's just not going to work out. Yeah? There are, of course, ways of solving it if it doesn't work in this form. You know, we can use quadratic formula or something like that. But for now, these problems are very specific, which means if you see something and you pull out like a 2 or a 3 or a 4 or whatever it is, and you don't end up with these two terms the same, you should check your work because you probably made a mistake. Does that make sense? Does that make sense, guys? So the thing that I'm pointing to is not necessarily your capacity to make a mistake, as we all certainly do have, but that these problems are very specifically set up. Okay? So they're kind of they're very special types of questions. All right, so that end up working this way. So we group our first two terms, negative 8x plus 3 times x plus 6 equals 0. And we set them both individually equal to 0 at negative 8x plus 3 equals 0. X plus 6 equals 0. Subtract the 3 from both sides. Negative 8x equals negative 3. Divide by both sides by negative 8. In class, a negative divided by a negative is a positive. So we get x equals 3 over 8. And then here we subtract 6 from both sides. And we get x equals negative 6. And those are our two answers. X equals 3/8 and x equals negative 6. Any questions on how we accomplish this? No? Okay. Almost there. All right, here we go. So, last thing, before I release you guys to do homework, you guys have the fortunate benefit of not having this class during homecoming week. My other classes had this class during homecoming week. So I made the homework very limited because it was homecoming week. So you guys get to have the benefit of that too. That's pretty cool. So this is a word question here. So solving real world problems. The height of one diver above the water during a dive can be modeled by the equation h equals -4 times 4t plus 5 times t minus 3, where h is the height in feet and t is the time in seconds. Find the time it takes for the diver to reach the water. Okay. So let's take a look at this. The height of one diver above the water. That's a key thing right there, above the water. The height above the water can be modeled by the equation here, where h is height in feet h is height in feet and t is time in seconds. And it says find the time it takes for the diver to reach the water. Okay, so first thing, what is it asking for? It says find the time, so it's asking to solve for t. So t equals what? What else do we know? The time when what? The diver does what? Reaches the water. Well, when the diver reaches the water, what do we know? What do we know? What does that mean for maybe the variables in our equation? What does that mean about h? H is the height above the water. Well, what's his height above the water when he reaches the water? 0. So we know at this time that we're looking for, h is equal to 0. Very good. So that's the information we've got with our equation, and we know we're looking for time is equal to 0. So what should we do with that h equals 0? What should we do? Begins with a P. Plug it in. We plug in the h equals 0 into our equation. So 0 equals -4 times 4t plus 5 times t minus 3. You guys see that? So what do? We plug in h equals 0 into our equation. That's cool. But now, wait a second. We have something times something else equals 0. How do we solve for t? What do you think? We have this times this equals 0. Well, what do I know about each of them? That either they must be equal to 0. Either one or the other has to be equal to 0, right? That's what we've been learning this whole time, is that the zero product property says if something times something else is equal to 0, then either this is 0 or this is 0. Does that make sense? And so how we solve is we just set them individually equal to 0. Good. So this one here, I subtract 5 from both sides. And I wind up with 4t equals -5. And then divide by 4 on both sides. I end up with t equals -5 over 4. This one is just a one-step equation. We add 3 to both sides and we get t equals 3. And t equals -5 over 4. So, the simple question, on what time does the diver reach the water? And so we have these two possible answers. What's the answer? What?
3.
Why not -5 over 4?
Time can't be negative.
Right. Generally speaking, we don't talk about going backwards in time. Okay? So the diver's not like time traveling until he hit the water. So, no. He's just diving. Okay? Much easier than time traveling. So t equals 3. That's our answer. Cool? You guys got that? You see how that was the solution to a real world problem? T equals 3. That's it. All right. You guys got that? So, homework. What is our homework? Our homework is number 1, number 3, number 9, number 14, and number 15. 1, 3, 1, 3, 6, sorry. 1, 3, 6, 9, 14, and 15. I'll write it down. It's page 288. Page number 288. Numbers 1, 3, 6, 9, 14, and 15. That's due next class. And of course, next class you will have the test review, and the test after that you will, or the class after that you will have the test. Okay? Test on Thursday. Tomorrow you guys have your test review, and remember my helps classes is tomorrow as well. Any questions? Guys, you got 6 homework problems, and you've got about 10 minutes. I think you can finish. So just go for it. All right? Yeah? Sure. Go right ahead.